Hello, good morning. My name is Enrique Paredes. I'm today here at Wittgenstein booth presenting our Quintauris Test Automation Framework. And I want to start by basically defining it as the first RISC-V ecosystem validation and benchmarking framework where we want to enable users of RISC-V to adopt the technology so that we enable like the software ecosystem from top to bottom. So the latest releases from Quintauris has been the real-time automotive platform, the RT Europa, and the validation and test automation framework, the QNTAF from Quintauris, is trying to enable the actual first steps into adopting the technology. So the test automation framework is automated, as I was saying, infrastructure based that can be actually deployed on premises or in our own data center as a service to customers. So I will cover high level firstly the first tier of the product. So the product will have like three elements or three focuses in the tool. We will start with evaluation of RISC-V cores and the running of software benchmarks and validation workflows. Then we will continue with paths to certification and orchestrations of those workflows. So initially, as you can see here, we'll have a starting point of a dashboard of the tool where at the moment an actual live entity or instance of the service that is run in our cloud, in our premises, in the data center. So we could run actually our benchmarks. The idea here is that we support a set of execution platforms, environments, IP cores, and operating systems. And after we select the environment configuration, we could create the tests and benchmarks that we want to actually run. So, for example, the platform in itself supports both simulation and virtual environment and physical environments. And in this sense, we have our server connected to SOCs and FPGAs where customers could access and run their workflows. The idea is that if we select, for example, simulation, QEMU, or virtualizer, these are currently the two environments that we support in the simulation side, and we could actually try to get a hold of several versions of the simulation environments for the 32-bit compliant or close to compliant to the RT Europa 32-bit RISC-V specification. So if we get, for example, one of our main IPs that we have in simulation, which is the RT Europa with Andes D45FS, we could select the operating systems that are actually currently ported to it. In this case, it's bare metal executions, but if we go for a generic RISC-V core, we have in this environment operating systems like ThreadX, Sapphire, FreeRTOS, or SAFERTOS. The idea here is that we could select the different combinations, and for example, we are working very closely with Synopsys, our partners Synopsys and Infineon, and as the first IP that has been recognized as compliant with RT Europa, we have included it into our environment, the simulation of the Aurix for the Synopsys virtualizer. And as you can see, we could select the Aurix and select different operating systems. In this case, let's select, for example, the SAFERTOS operating system. Now we set the parameters and we go to a page where we could actually select the set of benchmarks that we could run in this operating system. So at the moment, we have the core mark validation workflow, but the intention is to include more and more benchmarks in each of the industries or environments that we are focused on. The moment RT Europa focuses a lot or mainly into the automotive world, so these are the benchmarks that we are planning to have at some point enabled, from MBench to spec or autobench, right? We have all these benchmarks. We can actually launch the tests and basically disconnect to the central computer and enables the toolchain enablement, the license enablement, so that software developers do not need to actually install and waste days just by installing the software. Finally, we could have a look at the results. Obviously, we have a set of results already in place. We have the current simulation running. Some simulations will take longer than others, obviously, depending on the workflow of timing that we have created. And as the last part, we could do, obviously, filtering and selection of dates, selection of environments, and so on. But the tool is ready to make comparisons and visualization of the actual results, right? So, for example, imagine that we want to compare all the generic core 32 bits in QEMU that we have for the different operating systems and both bare metal or with a specific operating system. Also, we can select the specific test suite, if it's a Cormark, a Drystone, or Hello World, or any other, right? So the idea is that we could create custom graphs enabling the users to create their own reports, right? There are two at the moment ways of representing the graphics. One with a typical histogram, another one with a radar, where we have at the moment, this is synthetic data, where it can show like the differences between the different implementations and the different elements that we have selected, cores comparisons, operating system comparisons, test suites comparisons, and make a nice diagram into how it could look like.